Hello viewers, welcome to my YouTube channel. I hope this finds you well. Before we continue, I would like to request you to subscribe to my YouTube channel. I'm Zui, and I will really appreciate. Don't forget to hit the bell so that once I upload, you'll be notified. Now, today we want to look at some computation of a question here on probability, simple probability. And we have a question that reads, a bag contains 7 red counters and 4 blue counters. 2 counters are picked from the bag at random without replacement. The first part of the question is, represent the events using a tree diagram. The second is, find the probability that the 2 counters picked are of the same color. And part 3 of the question is, find the probability that the 2 counters picked were not red. So first we get to know that once the counters have been picked, they are not replaced. The 2 counters that are going to be picked, they are not going to be replaced. So it means the bag, in as much as it has counters inside there, they are reducing one after the other. So let's embark on our solution. This is the solution or solutions, because we have part A, part B, and part C. Now first we get to understand that this bag contains this number of counters. It contains 7 red counters, and then it also contains 4 blue counters. In total, they are 11. That is 7 plus 4. So in that bag, we expect to get 11 counters. So now on tree diagram, we are going to have a representation by solving in the part A. We are going to have 2 branches, so that the first branch, this branch here, we can write it as red, and this other branch we write it as blue. And now this means, or this column represents first pick. So first pick means we are going to have 2 branches, one for red, another one for blue. So now if in case one picks, let me say I pick a red out of the 11 counters that are in the back, it means the probability of picking a red, that means randomly, I assume I've closed my eyes and then I mix up the counters within that basket or bag. Then I just pick without getting to know which one I'm picking. Then it means the probability of picking a red one should be 7 divided by 11. And now the probability of picking a blue one, it means it is 4, the number of blue divided by the total. So for the second pick, it means again for each we have 2 branches. When a tree grows, we expect branches to come up, more branches to emanate from the existing branches. So then it means at this point we also expect to have 2 branches, and then at this other point we also expect to have 2 branches. Now these branches we can again label as R blue, R blue. Now this column we call it second pick. So because we are not replacing, it means once we picked one of the balls, they are going to remain 10 in that particular bag. And now let's say we picked that ball, you did not open the eyes, you were told by whoever observing that you have picked red or you have picked blue. Now it means you are remaining with 10 inside that bag. Now you come here. Next pick is, if in case you pick another red, it means you are going to have now 6 in total all over 10. And because for this pick we are not going to interfere with the blue, it means blue ones still remains, but now the total remains 10 because we had already picked the first one in the first pick. Now, but in case, what if you picked blue in the first case? It means that the red remained 7 all over 10 because now you had picked blue and now the red has not been interfered with. And now for this case, it means if you pick another blue, it remains, you are going to have the probability of 3 all over 10. So learners or whoever is watching, first you have to consider that if you have done the first one, the second one depends on what you did at first. Like for this case, if probability for picking red is 7, because 7 is the number of red, and then probability of picking blue is 4 because 4 is the total. So if you pick once, it means you are left with 10. So in the next pick, if you pick red, it means you have reduced 7 to 6. The probability will be the 6 that are available over the 10, which is the total because 1 is already gone. Now in this case, the probability for picking blue remains at the same because this is the second pick and only red has been picked. Remains 4, but the total is 10. When you come here, if you picked blue, if you pick another blue, it means the remaining ones are 3, but now red are same. We are not interfering with this branch. The red ones remained 7 out of 10. 10 because we have reduced the total number. So now here we are going to have probability of red, and then this one is probability of red-blue, and this one is probability of blue-red, and this one is probability of blue-blue. So now we come back to our part B of the question. Part B says, find the probability that the two counters picked are of the same color. So here are same color and here are same color. So probability of picking same color of the counters, it means you are going to have probability of red, or probability of blue. Now you come here and you say red means multiplication. So red is 7 all over 11 multiply by 6 all over 10. Or means addition. So this one now becomes blue is 4 all over 11 times 3 all over 10. And this one is going to be simplified. This is 42 all over 110 plus 12 all over 110. This one can be simplified to 4, 5 all over 110. And this one can be simplified to 28 all over, this one is 5. So that the probability of picking same color is 28 over 55. Let's proceed to part C. Now part C of the question reads, find the probability that the two counters picked were not red. Were not red, it means they were all not red. So it means it is probability of red, blue, or probability of blue, red, or probability of blue. The question is, find the probability that the 2 counters picked were not red. It means they were all blue. They were all so that means they were not red. Either they were blue, or they were red-blue, or they are blue-red, in that order. So we are going to take probability red-blue, and this one is 7 all over 11, multiply by, this is red-blue, 4 all over 10, brackets, you add probability BR, that is BR, 4 all over 11, multiply by 7 all over 10, plus blue by 11 times 3 all over 10. So we simplify. This is 28 all over 110 plus 28 all over 110 plus 12 all over 110, and this one is 56 plus 12, which is 68 all over 110, and this one 3 cuts or cancels here, 3 4 2 I mean, goes there 3 4, and it goes there 5. So the probability becomes that 4 all over 55. That's the probability that the 2 balls counters that were picked were not red. It means they were either red-blue or blue-red or blue-blue. Thank you very much for watching.